All right, guys, I just want to go over a few things for your quiz on Thursday and Friday in case you want to study for this thing. It's an intro quiz. It's really a quiz because it's only worth 17 points, okay? So I wouldn't get too worried about it, but it is a 17-point quiz. Things that you'll see on this, you definitely should know what a light year is. It's a distance that light travels in 1 year. And also, if you had a light year, or say light speed, and you wanted to convert light speed to a light year, you have to do that calculation, which we did in class. Light travels 3.0 times 10 to the fifth kilometers per second. So you're going to convert that to kilometers per year. Dimensional analysis, convert to years, you'll get a very, very big number, okay, in kilometers. You guys should know your scientific notation stuff, right? I mean, you should know what this means. And if you multiply this number by another scientific notation number, you should be able to do that. You can use your calculator to do that, but I just want you to be aware of that. Basic stuff about the Earth, the Sun, all the planets, and how close things are, how far away things are, about scale. Remember, we're located in the Milky Way galaxy, and we're on an outer arm of the Milky Way galaxy. So there's some multiple choice questions, MCQs, that are really, really quite simple. There's only 7 of them. They're 1 point apiece, and then the short answer, which might be a little bit more challenging, are 2 points apiece, and there are 1, 2, 3, 4, 5 of those altogether. So there's only 12 questions. Okay. Now, things you should know about the short answer. You should know that, one of the short answer is that light speed question I was just talking about. But another one is related to the Eratosthenes video, which you are either watching the day before this test, or you're watching it the day before this test. So Eratosthenes measured the whole entire circumference of the Earth. There were 2 sticks, right, and in 2 different places. He figured out how far it was from here to here, and he also figured out the angle difference between those 2 sticks that were in the ground, those 2 obelisks, the well and the obelisk in Alexandria, and the well in Syene. And so he figured out that angular difference. So the angle difference, the whole entire circle is 360 degrees. So if let's say the angular distance here, our difference is 20 degrees divided by 360 degrees. We know how far this is from here to here. We'll call that x. We'll say x is, 1,000 kilometers. Okay, represents the 20-degree part of this. We want to know what the entire thing is. We'll call that the circumference of the Earth, right? So I'll call it C. And so you're just going to solve for C. Not very challenging, but that's what you're doing on that one question. There's also a question about the equinox. So you have to go back and look at your notes on equinox. The equinox, we measured a stick and its shadow. And essentially, if I know what this is the height of the stick. This is the length of the shadow. And you haven't basically this number and this number. We want to figure out this angle right here. We'll call that question mark. Okay, that's going to give you the altitude of the sun in the sky. Okay, so that's going to give you your height above the ground, your altitude of the sun. You have to take that 90 minus question mark to get your latitude. Okay, that's how you do that question. So we did that in class on the equinox day. All right. Additional questions. Solar system scale. Solar system scale lab. You might recall that we were converting measurements to a scale model. If the sun was 1 meter, but the actual sun is a really big number, 1,392,000 kilometers, and we want to convert this in our scale, we're going to use that number to convert, right? We just have to divide 1 by that. You're going to get a really tiny number, okay? I'll say tiny number. And that number we're going to use to multiply by anything to get our scale model. So let's say that Jupiter, actually, we'll use Jupiter. Let's say Jupiter has a diameter of 142,984 kilometers. Okay, well, we just take that tiny number and multiply by that, and that will give us our scale model of Jupiter. Okay, that's what you guys did for that lab. All right, and then one more other question. We just did parallax in class, and parallax, you had a question mark. It's kind of like the equinox question. We're trying to figure out the distance from the sun to a star, which is over here. This is our question mark. We know the distance to our planet. So let's say that this distance is, I don't know, 5 meters, okay? And we measure this angle right here. Let's say that angle is, I don't know, 70 degrees, okay? Well, now I just have to do the tangent function, right? Because it's opposite over adjacent. Tangent of 70 is going to be equal to the question mark, the opposite over the adjacent, which is 5 meters. And then you just solve for the question mark. Bring the 5 over there, multiply by tangent of 70, and that's going to give you your answer. Okay, so that's your quiz in a nutshell. I basically gave you every single question. Now you just got to do it yourself. Okay? All right.